Hey guys, welcome to ANS Academy. In this video, I'm continuing the video I've made on limits yesterday. As usual, I've brought two problems in this video for you. For this is the first problem you can see on screen. So basically, we are not going to just solve the problem, but we are going to discuss about it and the methods we use and what formulas do we require in order to solve this kind of problems. So the problem on screen is limit n tends to infinity 1 upon n to the power 2020 summation k equals to 1 to n k plus 2019 and this thing whole to the power 2019. This is our problem. Now we need to solve it. But see, this kind of problems, we do not really have the best of ways to solve it generally because it looks so massive that if it comes in an examination, people just become baffled by it and they lose a lot of time. So the thing is, there are multiple ways to do this. But since this kind of things sum up to like we do not know if this is more than n to the power 2020, so you cannot just say that yeah, since the power of n is 2019 in the numerator, that means that yeah, it should be less than this, so that means it diverges. That means the new denominator is greater than the numerator and yeah, it should be 0. No, it's not like that because we do not know, because the numerator is the sum and the denominator is simply a function of n. So there are multiple terms in the numerator. The best way to approach this is in fact the Stolz-Cesaro theorem, whose link I've provided in the description, and that video should be tagged with this video. So I've already given this video once on my channel, so I'm just putting in the link. And what does this say? So I won't really explain here, so you can just watch the video and learn it in completely, because just stating the fact simply would do you half good, and half good is no better than doing worse. So Stolz-Cesaro basically says that if you have two sequences an and bn, and under some conditions which are that bn is monotone and it is divergent, which is for the case infinity by infinity, so the limits of an by bn and an plus 1 minus an divided by bn plus 1 minus bn are equal. This happens, the limits of these two, just put a limit here, the limits of these two expressions are equal when bn is divergent and an is divergent, and yeah, bn is monotone. So these things do happen. Now both of the limits need to exist and then only they can be equal. I mean, if one of them diverges, then yeah, there is no way that's gonna exist. So we just need to see if an plus 1 minus an divided by bn plus 1 minus bn exists, because we shall take an as k, this summation, and bn as n to the power 2020. So let an equals to summation k equals to 1 to n k plus 2019 to the power 2019, and obviously let bn equals to n to the power 2020. So if this limit exists, so does an by bn, which we want to find, and the values of the limits should be equal. So see, an is sum, that means an plus 1 minus an plus 1 minus an should actually give you the n plus 1th term, right? Of if k, this is the b of k, then you should give n plus 1 plus 2019, that is n plus 2020 to the power 2019, and that's what it should give. And what is bn plus 1 minus bn? Bn plus 1 minus bn shall give you n plus 2020, sorry, not n plus 2020, n plus 1 to the power 2020. Yeah, n plus 1 to the power 2020 minus n to the power 2020. And yeah, if you just simplify this bn plus 1 minus bn a bit, the leading terms of n to the power 2020 cancels off, and what is left is 2020 into n to the power 2019 plus all the lower powers of n. So when you divide this, the numerator of n plus 1 minus an is also basically n to the power 2019 plus lower terms of n. So if you divide both the when you do the n plus 1 minus an divided by bn plus 1 minus bn, you divide by n to the power 2019 up and down, and you get, and everything else cancels off because everything is a lower power of n. So when you apply the limit, everything else becomes 0. So you only have 1 by 2020. So this thing, division, gives you limit n tends to infinity a n plus 1 minus a n divided by b n plus 1 minus b n, and this gives you 1 plus all lower powers divided by 2020 plus all lower powers, which will give you 2020, and which is also the answer to our question, because as we stated by Stolze-Cesaro theorem, we have limit n tends to infinity a n by b n also equals to the same thing. So that's how it's meant to be done. So Stolze-Cesaro theorem, a very important tool for doing objective problems very quickly. So yeah, do study it. So we shall move to the next problem. Okay, the next problem says that, yeah, prove that limit n tends to infinity sine of 1 plus 2 into sine of half plus n into sine of 1 by n whole divided by n is equals to 1. If you cannot see 1, if 1 is out of the screen, so I'll just clarify, this is 1. Okay, now how do we do this? To do this, we shall use a very known theorem on limits, which is taught in college first year real analysis courses, introductory real analysis courses. That is, for a bounded sequence, and yeah, obviously convergent, for a bounded and convergent sequence xn. So if you have a bounded and convergent sequence xn such that limit xn is equals to a, if this happens to be true, then by the theorem we are talking about, we also have that k equals to 1 to n, and there is a 1 by n outside, x of k, the limit of this thing also is equals to a. Now using this can be done easily, because you just have to take x of k equals to k into sine of 1 by k, and indeed the limit of this is 1. If you have difficulties in proving that the limit is 1, and sorry for the background noise, I mean I cannot control right now. So limit k tends to infinity k sine of 1 by k, just put k equals to 1 by x, so you will get limit x tends to 0 sine x upon x, which indeed is 1. So yeah, xk becomes 1. So this thing is exactly our problem, which also becomes 1. Now how do we prove it? How do we prove that limit xn is a, then this a? So I'll just give you a hint. I'm not going to complete the problem here. So my hint here is that suppose you have limit xn equals to a. Now you need to know the definition of limits, from which you can say that xn minus a should be less than epsilon. Okay, this thing should be less than epsilon, where epsilon greater than 0, and this should hold for all n greater than equal to capital N, which is also dependent on epsilon. So that's the take out from this formula. Now you have to calculate the next thing, that is bn, which is equals to how much? 1 by n and x1 plus x2 up to xn. This is the next thing, and you need to prove the limit. So you're trying to prove that this thing also converges to a. Okay, fine. So we have bn minus a. Bn is basically summation k equals to 1 to n 1 by n xk minus a, right? So now whenever you have reached this state, now after this there is a simple step of manipulations which you need to do, so which I will leave as an exercise, because this is basically introductory real analysis. So even if you don't know, you do not need to ask anyone, just search Cauchy's theorem on first limits, but do not search until you have done it, because this is easy. Believe me, this is easy. What you need to use, I'll still give a hint. You need to use the triangle inequality. So somehow you need to use that summation k equals to 1 to n xk, the modulus of this should be equals to summation k equals to 1 to n modulus of xk. This thing is needed to be used, and you need to figure out how to use it, and you need to do something about this a. You need to put it inside, but how do you do it? See, that's also something you should consider, because one way is you can write minus a as summation k equals to 1 to n minus an by n, and then after getting it in the numerator you can put a inside every xk. That is, you can write this summation in the form summation k equals to 1 to n xk minus a by n. This could have been written. Okay, so that's the takeout from this. So this can be written as 1 by n summation k equals to 1 to n xk minus a. Okay, and when you have done this you can still write now less than equals to 1 by n, and the summation comes out k equals to 1 to n, and you only get xk minus a in the modulus, but you still have this xn minus a less than f epsilon for n greater than equal to n, right? But what happens if n is not greater than equal to n? So there is some point behind that. So behind that you can actually say the numbers are bounded, because after that it is obviously bounded, that's for sure. But what happens to the numbers before? So in that way you can prove that this quantity is also bounded and it can be made as small as possible. And once you do that, that is it is less than some another epsilon 2. So once you do that, you prove that bn minus a is can be made less than any arbitrary number. That means bn tends to a when n goes to infinity. So anyways, so this was the entire purpose. So you need to understand that these problems are very good, and yeah, these tricks are very healthy. But so from the first problem we learned that Stolz's-Isardo theorem is useful. From the second one we learned that knowing this kind of sequence and limit problems is very useful in solving objective problems that seem very weird. And third is, if even by any chance it comes in subjective, you need to know how to derive it. So I just showed you how to derive it, and the rest you need to complete on yourself. So I think even if I was saying that I won't show it, but I showed almost 90% of it. So the 10% is up to you, so you need to do it. And there are many more theorems like this, many more theorems which are not mentioned in books, but yeah, they are in textbooks where they should be, but not really everywhere. So those kind of problems I'll bring them to you, no worries. Okay, so let me know in the comments how do you like this video. Thank you.